All right. Good morning, everybody. Welcome to day 3 of AMA Junior Camp for 2022. My name is Kyle Thiede. I'm the education specialist here at the AMA headquarters, and I am really excited about the activity we have ready for you this morning. So if you watched yesterday's broadcast, we heard from Rick Crosland, one of our favorite science educators who's helped us out on a lot of things. And he told us all about Bernoulli's principle, which is a scientific law about how fluids behave. And we did a demonstration even here in the studio with our Bernoulli bag. So hope you guys got a lot of enjoyment out of that. And I hear that some of you are even still playing with your Bernoulli bags. So that's great to hear. But we're going to go a little bit further in depth today about what exactly fluids even are. Remember from yesterday, Bernoulli's principle was all about how fluids behave. If you increase the speed, what happens to the pressure and vice versa. Well, today we're going to be pulling things a little bit further back and talking about just what fluids are in the first place and why it matters. So I've got my AMA Junior Camp flight pack here, and some of you probably have yours all out and ready to go as well. And if you open it up and go through your project number 3 envelope, you'll see a lot of the same things that I have laid out on the table here. And if you don't have an AMA Junior Camp flight pack, let me take a quick moment just to go over what I've got here. And I'm sure that these are things that a lot of you may have just in your kitchen or in your house already. So I've got just a bottle here, just a plain plastic bottle. I've got a little bit of vinegar. And if you got the Junior Camp flight pack, this is, I believe, 2 ounces of vinegar. You want just about that amount. It's not super critical exactly how much you have, but as long as you have something about this much. Got some baking soda here. I've got a funnel. I've got some balloons, which you may or may not have on hand, but I've got about 4 of them here. And I've also got something to help me scoop the baking powder. So that is what we're going to be working with for this first experiment. So the thing to know about fluids is that just like everything else that exists, they are made out of molecules. And molecules are tiny, tiny little particles that are way too small for you to see with the naked eye, but they make up everything around us. Everything that you see or can smell or taste or anything or touch is made up of molecules. And a big part about what makes things the type of thing that they are is how close those molecules are packed together. So things that are solid, like this table, or like your body, or like any of these materials, except for the vinegar, any of these materials are solids because their molecules, those particles, are packed very, very closely together, very closely together. Now, liquids, like the vinegar, the molecules are not quite as close together. They're less dense, is what we call that. They're less dense. So the molecules can kind of move around a little bit more, and that's why vinegar and other liquids like water can flow and do things like that. And then, of course, there's gases where the molecules are really far apart. And that would be like, air and oxygen and carbon dioxide and all other kinds of gases that we can sometimes see them, but even the gases that we can't see, we can still smell them, we can still breathe them, and they still impact the way that we go about our lives. So what we're going to do today is we're going to kind of see what the relationship is between solids, liquids, and gases, and maybe how they can interact. All right, so as far as fluids go, liquids and gases are what we would consider fluids. Solids, not so much, but liquids and gases, we would both consider fluids. So what we're going to be starting off with today is we're going to be doing a small experiment to see if we can combine a solid and a liquid to make a gas. All right, so that's what we're going to be doing first. All right, so I'm going to take my bottle here, and I'm going to take my vinegar, and I'm going to be very, very careful. And I'm going to pour about half of this vinegar into my bottle. I'm going to be very, very careful here. See if I can do it without spilling. That's not too bad. All right, that's a little more than half. And I got vinegar in the bottom of my bottle there. And now I'm going to take my funnel. All right, so what we're going to be trying to do here is combine the baking soda with the vinegar. And what I'm going to do here is I'm going to take my balloon, and I'm going to stretch it over the bottom of my funnel. All right. So there we go. And I'm going to take my little scoop here and my baking soda, and I'm going to scoop some baking soda into the funnel so that it drops down into the balloon. So the balloon will have some of this baking soda in it. And again, it doesn't really matter exactly how much baking soda you use for this. I mean, it does make a difference. The more baking soda you use, the bigger the reaction is going to be. But you want to use maybe about a teaspoon. And I think I put in a little bit more than a teaspoon into my balloon, but that's okay. About a teaspoon. So I've got that in the balloon now, and I'm going to roll it back off of the funnel. Set that aside. And if you need to use the funnel to put the vinegar in the bottle, you can use that for that as well. I would just recommend that if you do it that way, make sure the funnel is clean before you put the baking soda into the funnel, and you'll see why in just a second. All right, so now I'm going to take my balloon, I'm going to stretch the mouth of the balloon over the mouth of the bottle. All right, so we've got our bottle with this liquid in it. We've got our balloon that has some solids in it. And now I'm going to tip the balloon up so that the solids drop into the liquid, the baking soda drops into the vinegar, and we'll see what happens. All right, watch carefully. All right, so as you can see, there's a chemical reaction going on here. And the vinegar and the baking soda are reacting with each other and producing a gas, which is called carbon dioxide. Now, carbon dioxide is a gas that's around us all the time. It's actually what we breathe out. Whenever you take a breath, you're breathing in oxygen, and then you breathe out carbon dioxide. And luckily, that's what plants breathe in, and then they breathe out oxygen. So we kind of help each other out that way. But anyway, carbon dioxide is what is produced when we mix the baking soda and the vinegar. And that's why the balloon stood up, because that gas expanded into the bottle, and it expanded into the balloon as well. So that's one way that we can kind of control fluids, is we can figure out what kind of chemicals mix together in different states, solid or liquid, and we can use them to create new kinds of fluids. All right. But there's other ways that we can control what fluids do as well. And one of the best ways that we can control fluids is through temperature. All right. So if you look over here, I've got two bowls here. I've got a bowl of very, very cold water. There's some ice cubes in it, so it's ice cold. And I've also got a bowl here that I'm going to put some hot water in. All right, so if you are using anything that you use to heat up water, like if you're boiling water on a stove or you're microwaving it, be very, very careful and get help if you need it. Get help from a parent or an older sibling or someone who can help you, because you really don't want to spill hot water on yourself. You'll have a bad day very, very quickly. So I'm going to be careful here. And I have this pot of very hot water. I'm going to put some of it in my bowl here. All right, that should be enough. And now I'm going to take my bottle with the balloon on it, and I'm going to set it in both of these bowls, and we're going to see what happens when I do that. So I'm going to take my bottle, I'm going to set it in this bowl of hot water. Now watch and see what happens to the balloon. All right, it may be a little bit difficult to see on camera, but looking at it up close, I can definitely tell that the balloon is expanding a little bit. Like it had some wrinkles in it, and now it's much smoother, and I can tell that it's inflating a little bit. Now, why would it be doing that? There's not any more air in the bottle. We're not creating more carbon dioxide. The air isn't growing. The air isn't, increasing in amount, but it is spreading further apart. The air molecules are spreading further apart from each other. That's what happens when things heat up, is the molecules spread further apart and the density decreases. So that's why the balloon is inflating a little bit more when it's exposed to heat. The carbon dioxide, inside of it is expanding. All right, so now I'm going to take this bottle and set it in the cold water, and we'll see what happens now. All right, I can tell the balloon is getting a little bit more wrinkly. Because now, when you expose something to cold water, or when you expose something to cold temperatures, the molecules tend to get closer together again. All right, I can tell the balloon is getting a little bit more wrinkly again, and it may tip over here in just a second. Well, let's see. If you're having a hard time seeing exactly what's going on with this, there's a reason we sent more than one balloon with you. So I'm going to go ahead and take the balloon off of here. I'm going to take this balloon off. I'm going to let some of that carbon dioxide get out. I'm going to let the air inside the bottle just kind of reach a natural level. I'm going to let the air outside and the air inside the bottle equalize. I'm going to put the balloon on it, a fresh balloon on it, and we'll see what we can observe by exposing this balloon to hot and cold water. We'll see if we can tell a difference. Yeah, look at that. The balloon popped up a little bit. My seal isn't great here. My seal is a little leaky, but you can see that the balloon kind of popped up a little bit and started to inflate with some of that warm air. And if we go ahead and put it in the cold water, it flops back down. Yeah, that's flat now. All right. And of course, if you're doing this experiment at home with the materials in your pack or the materials that you just have in your kitchen, of course, you can always experiment with how much vinegar you're using. You can experiment with how much baking soda you're using. You can experiment with how cold and how hot your water is. And you have plenty of balloons to try it over and over again too. There are 4 balloons in your flight pack, I believe. So you should be able to try this experiment a couple different ways and see if you can get the balloon to inflate bigger or smaller amounts. But that is why it does what it does. That's how molecules work. And that's how we can combine solids and liquids to get gases, and how gases behave when they're exposed to cold and to hot. Now, there's one more thing that we're going to do here before we finish off this live stream. Now, this is something that we did not include in your junior camp flight pack, but if it's something that you want to try at home, we want to make sure that you do it very, very, very carefully. All right? Because what we're going to be doing is we're going to be working with a little bit of flame. All right. And to help me with that, I have Kyle Jarris with me, and he's going to help us out with this experiment because you may need an extra set of hands to help you with this particular experiment. So Kyle, thanks for being here.
Oh man, happy to be here.
I know that it's earlier than you usually are in the studio, but we'll go ahead and give this a try here. So the first thing we're going to do is we are going to make some more carbon dioxide in this jar. We've already got some vinegar in it, and we're going to put some more baking soda in it. And again, there's no jar like this in your flight pack. This is not something that is in your flight pack. And again, if you are doing anything like this at home, make sure you have help and make sure you're being as safe as you can be.
This is the parental disclaimer. Like, this one has to be done by someone who's in charge. All right, let's set that on top for you.
All right. So we're making a lot of carbon dioxide. You can see I put a lot of baking soda, a lot of vinegar in here, and we're getting a lot of it in there. And now what we're going to do is we are going to take a candle and we're going to have a flame. So one of the things that flames absolutely need is they need oxygen, just like people do. Flames breathe oxygen, but they cannot breathe carbon dioxide, and neither can people for that matter. So we have all this carbon dioxide in the jar, and we can use that as a fluid. We can use that as a fluid to put out the candle just like you could with water or any other kind of liquid. Well, not any other kind of liquid. There are plenty of other liquids that would make this flame grow bigger. But carbon dioxide is a gas that will extinguish this flame just as well as water or any other. All right. So what we did is we took the gas in this jar and we poured it. We poured it just like we would a liquid into this ramp, and it flowed down the ramp and put out the candle. Now, why would it flow down the ramp? Because it's a fluid. And carbon dioxide is more dense than the surrounding air. More dense things will settle down to the ground. Less dense things will rise up. So that's why the carbon dioxide behaved like it did, and it put out the candle. And again, if you want to try that at home, be as safe as you can. Make sure you have somebody who knows how to handle flames, who knows how to handle hot things, and make sure you have an extra set of hands to help you out with holding the ramp and pouring the jar and all of those things. So, thanks for your help, Kyle, and we'll see Kyle again this afternoon because this afternoon I'm really excited about the guest speaker that we have this afternoon. We saw him yesterday in the video. Rick Crosland is actually going to be joining us live. He's not going to be in the studio, but he is going to be live answering the questions that we have for him. I know we've got a lot of questions for him, and I'm sure you guys have got a lot of questions for him also. And he is a great teacher. Anyone who's ever had a great teacher knows how valuable they are and knows how great it is to be able to just talk with them. And Rick is one of the best out there. So we're very, very excited to have him on this afternoon. And be sure that you join us for that live stream at 3 o'clock Eastern Daylight Time. And in the meantime, like I said, you can experiment with all the things that you've got here in the flight pack. And even if you don't have them in the flight pack, you probably have baking powder and vinegar in your kitchen. So make sure that you try it a few different ways. You can experiment with the amounts. Just don't waste all of your mom's baking supplies. Make sure you have permission to do that. But experiment with different amounts, experiment with different temperatures, and see what you can get the balloon to do. And again, if you want to try out something a little bit more daring, make sure that you're being safe when you do so. All right, and share any experiences that you want to share with us using the hashtag AMA Junior Camp on social media. And we're very excited to see what it is you guys are coming up with and how you guys are participating in this experience. I know I'm having a great time, and we're going to have a great time this afternoon with Rick. And in the meantime, enjoy your day, and we'll see you later.